So this is the 2014 Junior Cert Higher Level Paper 2, and we're looking at question number 8. The equation of the line L is x minus 3y minus 6 equals 0. Find the slope of the line L. Okay, so if we're trying to find the slope, one way we can do that is by using this formula here from our tables book. If we can rearrange this equation here into this kind of shape, well then the m, which will be the number in front of x, will be the slope. So, if I have x minus 3y minus 6 is 0, I just want y on the left. So I'm going to move, first of all, this minus 6 over here. It becomes plus 6. I'm going to move the x over here, and that's going to become negative x. So that will give me minus 3y on the left is equal to negative x plus 6. So now what I can do is divide. I nearly have what I want. I just want y on the left, so I'm going to have to divide this by minus 3, because then these will cancel. But if I divide that by minus 3, I've got to divide everything by minus 3. So what I get then is y is equal to, now remember, minus x is the same as minus 1x. So really what I have there is minus 1 over minus 3, which is just 1 over 3. So a third x, and then plus 6 divided by minus 3 is minus 2. So then I can see that my m value, which is the slope, will be the number in front of x, the coefficient of x, which is a third. So the slope is 1/3. Part 2 says, show that the point 1 minus 2 is not on the line L. Okay, well, if we substitute, if you want to find out if a point is on a line or on a curve or anything like that, you can substitute the point, which has an x and a y component, into the equation for x and y. So x minus 3y minus 6 is equal to 0. So if I replace the x with the number 1, minus 3 times the y, which is negative 2, and I still take away 6, is that equal to 0? So let's see. 1 minus 3y minus 2 is positive 6, so I get 1 plus 6 minus 6, and that gives me that 1 plus 6 minus 6, they combine to give 0, so that's telling me that 1 is equal to 0, and that's not true. 1 is not equal to 0. So if it's not true, therefore 1 minus 2 is not on the line. Okay, so finally, part 3, the line K passes through point 1 minus 2 and is parallel to the line L. Find the equation of the line K. Okay, well, if it passes through this point and it's parallel to the line L, if it's parallel to the line L, it means it has the same slope. So the slope of the line L was 1/3. So this line K will have the same slope. So our slope is 1/3. Our point is 1 minus 2. So 1 minus 2, that's our point. And we can use a formula here from the tables book. There's another formula for the equation of line, which is this one here. So if you have the slope m and a random point on the line, or any point on the line x1, y1, x1, y1, then you can use this formula to find the equation. So this would be our x1, minus 2 would be our y1. So we're going to substitute these then in here to this formula. So I have y minus y1 is equal to m bracket x minus x1. Always a good idea to write the formula out. And now I'm going to substitute in. Now this y and this x here will be part of the equation, part of your answer. So they'll be left alone. So y minus y1 is minus 2, protect that with a bracket there, is equal to the slope, which is 1/3 m, bracket x minus x1, and x1 is number 1. So tidying up now, minus 2 is positive 2, equals 1/3 x minus 1. Now some people might multiply this bracket out here, you can do that, but I like to get rid of the fraction first, so I'm just going to multiply everything by 3. So if I times the left by 3, I get 3y plus 6. Make sure you multiply each part by 3. And then over here, 1/3 of x minus 1, if I multiply that by 3, this fraction disappears and I'm just left with x minus 1. So now all that remains is to bring everything maybe to one side. So I'm going to bring the 3y over here. It's going to become negative 3y. And I'm going to bring the positive 6 over here. That's going to become negative 6. So that's going to leave me with 0 on one side and x minus 3y, and minus 1 minus 6 is minus 7 on the other side. So there's the equation of the line K. And that's the end of part 3 and the end of question 8.